Hello everyone, this is an Amarnath, Assistant Professor in Mathematics, Department of Humanities and Sciences, MLR Institute of Technology. It is a second lecture, continuation in the eigenvalues and eigenvectors of a matrix. Subject name linear algebra and calculus. In the last video lecture, we have studied about eigenvalues and eigenvectors concept, previous lecture, definitions, and how to find eigenvalue and eigenvector of a 2 cross 2 matrix. So that we have done, I think everyone can remember, that is to find eigenvalues we use det of a minus lambda I is equal to 0 characteristic equation. Using this equation we can find eigenvalue lambda and eigenvector x we can find, that we have done for 2 by 2 matrix. So today in the present lecture I am going to teach how to find eigenvalues and eigenvectors of 3 cross 3 matrix. It is very important one in the exam point of view, right? And for this also we have some alternate methods to find eigenvalues and eigenvectors. Some students feel difficult in finding determinant of the matrix. In that case we have one more formula to find eigenvalues and eigenvectors. These things we will discuss today. Let us take one example and find the eigenvalue and eigenvectors of a matrix. So look at the, here I am taking one problem. Find the characteristic roots of the matrix 2 2 1 1 3 1 1 2 2. It is a 3 by 3 matrix, right? So here, since it is a 3 by 3 matrix, how many eigenvalues will exist? For n cross n matrix, n eigenvalues. For 3 cross 3 matrix we get 3 eigenvalues, and corresponding each eigenvalue we should find 3 eigenvectors that we are going to find today. So since it is a 3 cross 3 matrix, to find eigenvalues we have to take a characteristic equation. So we can call the eigenvalues also characteristic roots, latent roots, or eigenvalues. Anything is same. And sometimes in the examination he may ask find the latent roots of the matrix or eigenvalues of the matrix, characteristic roots of the matrix. Anything is same. To find eigenvalues of the matrix we need to take characteristic equation that we have discussed in the last class, that is characteristic equation. Characteristic equation of A is det of a minus lambda I is equal to 0. This is a characteristic equation. So already we discussed how to subtract. Since it is identity matrix, the lambda should be subtracted from diagonal element 2 3 2. From this if you subtract minus lambda, that will be the a minus lambda I matrix. For that we need to find determinant. That is, it is very simple, det of, from the diagonal subtract lambda, 2 minus lambda, remaining elements as it is 2 1. So 1, second diagonal element 3 minus lambda 1, third row 1 2 2 minus lambda is equal to 0. Det, it is a determinant. We should not write the bracket. Some students use to write the brackets. Bracket means matrix. If you write the straight line, that will represent det of the matrix. So this determinant should be equated to 0. So we can find the unknown value lambda. So determinant expansion we know very well, 3 by 3 determinants. Or we have one alternate method to this one. First we discuss how to expand in the routine process, determinant expansion. We can expand any one of the row or any one of the column. Generally we expand first row. So first row sign, cofactor signs, what that is plus, minus, plus, we know, right? We need to expand. While expanding you write in this fashion, 2 minus lambda, first row, and leaving the element 2 minus lambda containing the first column and the first row, remaining left over this one. That is the determinant we have to find. That is bracket 3 minus lambda into 2 minus lambda minus 2. So this is a cofactor matrix of the 2 minus lambda into, so maintain the big bracket like this so that you will not do the mistake. Next, second element, first row, second element minus 2. So minus 2 containing this row and this column. Leave this row and leave this column. Remaining 4 elements 1 1 1 2 minus lambda. Determinant we have to find 1 into 2 minus lambda. 1 into 2 minus lambda, this one into this one. Next, minus 1 into 1, minus 1 into 1. So leaving the second element column and row 1 into 2 minus lambda minus 1 into 1. The last third element plus 1 into, so leaving this third element containing row and column, at this column and this row should be left, remaining this into this AD minus BC, 1 into 2 minus 1 into 3 minus lambda is equal to 0. Determinant value should be equated to 0. Most of the students, they don't write is equal to 0. That is mandatory. It is an equation. We are equating to 0. That is a rule for finding the eigenvalue, right? So we have expanded the first row 2 minus lambda to 1, leaving that elements containing row and column, and remaining elements determinants. That we have done here, right? Now let us simplify the equation. 2 minus lambda. Now, so multiplying 3 minus lambda and 2 minus lambda, directly we can multiply minus lambda into minus lambda, lambda square, 3 into minus lambda minus 3 lambda, minus lambda into 2 minus 2 lambda, that is total minus 5 lambda. Okay. Next, constant, coming to a constant, 3 into 2 6, 6 minus 2, that is plus 4. Okay, na? So directly I have simplified and written the product, total 2 into 2 4 terms, and the minus 2 is there, that I have written completely here, minus 2 into, look at this one, 1 into 2 2 minus 1, constant is 1, minus 1 into minus lambda, minus lambda. Okay. Third term plus 1 into 2 minus 1 into 3. So 2 minus 3 minus of minus plus lambda is equal to 0. Okay. Term by term, if you simplify, you will not get the mistake. That is 2 minus lambda into lambda square minus 5 lambda as it is, or we can multiply and write minus 2 lambda, multiply and write, plus 2 minus 3 minus 1, minus 1 into 1 minus 1 plus lambda is equal to 0. Okay. Right. Now multiply and write 2 term, multiply these 3 terms. Okay. 2 into lambda square, 2 lambda square minus 10 lambda plus 2 into 4 8 minus multiply with lambda, minus lambda into lambda square minus lambda cube minus of minus plus 5 lambda square minus 4 lambda. Okay. So multiplying with 2 lambda square minus 10 lambda plus 8, multiplying with minus lambda into lambda square minus lambda cube minus of minus plus 5 lambda square minus 4 lambda, minus 2 lambda minus 1 plus lambda is equal to 0. Simplifying this complete equation, highest degree term first we have to write, that is minus lambda cube, right? Next, lambda square terms. What are the lambda square terms here? 2 lambda square plus 5 lambda square, that is 7 lambda square. Next, minus 10 lambda, lambda terms, minus 10 lambda minus 14 lambda. Next, minus here minus 2 into minus, that is a plus 2 lambda. There is a minus 2 into 1 minus 2 minus plus 2 lambda, this is right. Minus 2 lambda, 10 lambda minus 4 lambda minus 14 lambda plus 2 lambda minus 12 lambda plus lambda, that is minus 11 lambda. And to simplify lambda terms, add and subtract the coefficients, right? Next, constant term, 8 minus 2, 6 minus 1, that is plus 5 is equal to 0, right? This is a characteristic equation. Finally, it is a cubic equation. Cubic equation means solving we get 3 roots. Quadratic equation 2 roots. It depends on the degree. So it is a nth degree root will give n roots. It is a cubic equation, third degree of the equation. So we have to get 3 roots, right? So or you can write with multiplication, multiplying with minus, you can get this is lambda cube minus 7 lambda square plus 11 lambda minus 5 is equal to 0. So anything is same, just the same equation, just multiplied with the minus, we got this equation. We need to solve this equation. How to solve? We have so many methods to solve the cubic equation. One is finding the trial method, substituting 1, 2, 3 like that, we can find the one root of the equation. See here, substituting, suppose lambda is equal to 1, we can call this a trial method. If you substitute lambda is equal to 1, so here 1 minus 7 plus 11 minus 5, that is minus 5 minus 7 minus 12 plus 12 minus 12, 0. It implies lambda is equal to 1 is a root, right. Similarly, we can solve this one using synthetic division method to get one more root. Actually, the cubic polynomial, we have to get the 3 roots, right. How to solve this one? Here I am using, look at this one, coefficients I am taking 1 minus 7 11 minus 5. Here I am writing, right, 1 cubic equation, cubic coefficient minus 7 11 minus 5. These are the coefficients. We call this is synthetic division method. So in the school level we used to study, and since you got the one root, you can divide with lambda is equal to 1. So how to do this synthetic division? First we need to write the coefficients, lambda cube coefficient, lambda square coefficient, lambda coefficient and constant. Suppose any term is missing, we have to put 0. Suppose lambda square is not there, you have to write 0. Lambda term is not there, you have to write 0. Right, but since here all terms are there, I have written the coefficients, lambda cube coefficient, lambda square coefficient, lambda coefficient and constant. Since we got the one root with the trial method, with that factor we need to divide. This is called synthetic division method. So in the synthetic division method, first we need to write here, put 0, right, adding 1 and 0, 1. Now multiply this one and this one, 1 into 1, 1. Now add minus 7 and 1, minus 6, 1 into minus 6, minus 6, add 11 and minus 6, 11 minus 6 plus 5. Now 1 into 5, 5, right. So minus 5 plus 5, 0. This is called remainder. One remainder 0, then your factor is correct. Okay. Now this is again second degree equation. First is cubic, this is second degree. Again I can divide with lambda is equal to 1. Why? Because here see 5 plus 1, 6, 6 minus 6, 0. So sum of the positive and negative terms here, 0 means 1 is a root. In the remainder theorem we have this condition. Again put 0, 1 plus 0, 1. So dividing with 1, 1 into 1, 1, minus 6 plus 1, minus 5, 1 into minus 5, minus 5, minus 5 plus 5, 0. So starting coefficient is lambda cube, second one is lambda square, this is lambda, this is constant. Okay. When you are dividing with lambda cube with lambda and lambda square, the leftover is lambda minus 5 factor. So already lambda is equal to 1 is a root, lambda 1 is equal to root. Now lambda minus 5 is equal to 0. Now 5 take to other side, lambda is equal to 5. So clearly we got 3 roots. And this equation can be written as lambda minus 1 into lambda minus 1 into lambda minus 5, which is equal to 0. So solving at lambda minus 1 is equal to 0 means lambda is equal to 1, lambda minus 1 is equal to 0 means lambda is equal to 1, lambda minus 5 is equal to 0 means lambda is equal to 5. Total how many roots we got? That is 1, 1, 5. So this is one of the method how to solve the roots of an equation. Lambda values, 3 roots we got. Right, I said very clearly, it is a cubic polynomial, we have to write 3. So some of the students, they will write this one, 1 comma 1, they will miss it here, right, 1 comma 1. It is a repeated root. Suppose if you use a scientific calculator, it won't show the duplicate root. At 1 it will show only lambda is equal to 1 and 5. The students also will write as it is. Now it is not correct. Third root is missing. So it is, since it is a cubic equation, 3 roots, and one of the root is repeated. If you use a scientific calculator, either 1 or 5. How to decide? That can be verified from our one small concept is there that we discussed in the last class. That is, sum of eigenvalues is equal to trace of the matrix. So here this is a principal diagonal elements sum, 2 plus 3 plus 2, 2 plus 3 5, 5 plus 2 7. That is a trace. Trace is equal to 2 plus 3 plus 2, that is equal to 7. Now sum of eigenvalues, that also should be same. See, 1 plus 1 plus 5 is equal to 7. See, trace of the matrix and sum of eigenvalues is equal. That is the checkpoint. So it is very important. Most of the students, they will do, suppose we have written 1 comma 5, 1 plus 5 6. So how much should be added here? 1 or 5. So I am telling one of the root is repeated, either 1 repeated or 5 repeated. Very simple. With the trace we can check. Trace is 2 plus 3 plus 2, 7. Sum of eigenvalues also must be 7. Here already we have 2 eigenvalues, 1 and 5, using scientific calculator. If I was showing 2, third one is not showing. Which is repeated? Either 1 may be repeated, 5 may be repeated. How much should be written here? 1 should be written. So that 1 plus 5 plus 1, that is 7. Okay. So that's why how to check the find the third missing eigenvalue. This is a method. So checkpoint is trace of the matrix is equal to sum of the eigenvalues. So this is a way to find. But most of the student, while finding this equation at the expansion, there is a chance for mistakes, plus minus mistakes, and they will get the roots in the decimal and they stop it. But here for that purpose, here I am going to teach another one shortcut method is there that I will teach. So suppose any students are unable to expand this determinant and they are not getting the proper equation, automatically roots also in the decimal, it is not correct. So sometimes some matrices will exist the roots in the decimal, but 1 comma 1 comma 5 here integers, if the equation is wrong, automatically the eigenvalue is also wrong. For that purpose, here I am going to teach one alternate method to find the roots of a matrix, characteristic roots. Let us see here problem. So last given problem here we have last problem, same problem I am taking 2 2 1 1 3 1 1 2 2, the previous problem. Yes, same, right. So same. So again alternate method, this I am calling alternate method. Alternate method to find eigenvalues, right. So generally as usual we take characteristic equation det of a minus lambda I is equal to 0, right. So minus lambda means, like as the previous problem, subtract the lambda from diagonal elements, remaining elements write as it is, because you are subtracting an identity matrix. Identity matrix means diagonal elements are 1, remaining elements are 0, right. 2 minus lambda 2 1 1 3 minus lambda 1 1 2 2 minus lambda is equal to 0. So students should not forget writing equal to 0, means characteristic equation it is, we are equating to 0, homogeneous system it is, right. But here I am not expanding the like as the previous one. So because I am telling the alternate method. So what is the alternate method to here? I am giving a formula it is. So we know it is a 3 by 3 matrix, definitely lambda q will get. So the starting letter will be lambda q. Next second one will be lambda square. So in the previous example also we have seen, that is S1 lambda square. I am writing some S1, some coefficient that we need to find, plus S2 lambda minus S3. So this will be the characteristic equation. Here we have 3 unknowns. What are the 3 unknowns? S1, S2, S3. That 3 should be determined. So what are S1, S2, S3 we will discuss now, and we write. Okay. So students has to remember this equation, lambda cube minus S1 lambda square plus S2 lambda minus S3 is equal to 0. This is a shortcut method I am telling, right. Those the students who are facing to expand the determinant and they are feeling difficult, that we are finding here, right. S1 is equal to trace of the matrix, trace of A. Trace means we know very well the sum of the principal diagonal elements, that is 2 plus 3 plus 2, which is equal to 7. That is S1 value. S1 is equal to 7. Next, coming to the S2, this is important. How to find S2 means, right, this is sum of cofactors of principal diagonal elements, principal diagonal elements, that I will explain, right. So what are the principal diagonal elements? 2 3 2. Okay. So suppose here this matrix 2 2 1 1 3 1 1 2 2. So first principal diagonal means is 2. So leaving this to containing row and a column. What is left over? Remaining 3, 1, 2, 2. It is a 2 by 2 matrix that determines, right? 3, 1, 2, 2. This is the first one. Leaving the first diagonal element 2 row and column, remaining 2 by 2 matrix determinant we are writing. Next, second, see this one again I am writing to make you understand. So this is a matrix. Second principal diagonal element is 3. So here this 3 containing row and column. So here this is a 3 contains this row and this column. Now what are the leftover element? 4 elements are left over. 2, 1, 1, 2. That determinant we have to write. That is 2, 1, 1, 2. Okay, na? That is the second principal diagonal element about cofactor of 3. Next, plus 2, third cofactor. So 2, 2, 1, 1, 3, 1 and 1, 2, 2. So third diagonal element is 3. And these 2 containing row and column we need to leave. And what is left over? 2, 2, 1, 3. That one determines 2, 2, 1, 3. So this sum of these 3 we need to write. So it is a determinant we know AD minus BC, det of 2 by 2 matrix. 3 to the 6, 6 minus 2, 4 plus 2 to the 4, 4 minus 1, 3. 2 to the 6, 6 minus 2, 4. Okay, now once again check. 3 to the 6, 6 minus 2, 4. 2 to the 4, 4 minus 1, 3. 2 to the 6, 6 minus 2, 4. How much this is? 4 plus 3, 7, 7 plus 4, 11. Right. Now the S2 value is 11. Okay. So one more left over, S3. See, these are the 3 formulas you need to remember. S1, S2, S3. S3 is det of A, determinant of the matrix. S1 is trace of the matrix. S3 is det of the matrix. Okay. S2 I explained sum of the cofactors of principal diagonal elements, 3 determinant summation we have done. So S3 determinant we can do very easily, that you know very well. So det of the matrix everybody can expand. Say det of 2, 2, 1, 1, 3, 1, 1, 2, 2. So determinant means expanding any one of the row. So first 2 as usual we are expanding 2 into, leaving the row and column. So 3 and this one, 3 to the 6, 6 minus 2, 4. Directly I am writing minus 2, leaving the second row and first column. 1 into 2, 2, 2 minus 1, 1 plus third element 1, leaving the third column and first row. 1 into 2, 2 minus 3, 2 minus 3 minus 1. So this is equal to 2 for the 8 minus 2 minus 1, 8 minus 3 which is equal to 5. So S3 is equal to 5. S3 is equal to 5. See, if we have determined required, this is called as equation 1. So S1, S2, S3, we have determined all 3 coefficients. Substitute in equation 1. Substitute in equation 1. What is the equation 1? Lambda cube as it is minus S1. S1 is 7. 7 lambda square. S2 lambda. S2 plus 11 lambda minus S3 minus 5. It is a cubic equation. See, we can check with the previous slide, we got the same equation or not, right? Let us go back to the previous slide. See, lambda cube, see this equation, see, minus 7 lambda square plus 11 lambda minus 5 is equal to 0. We got in the previous expansion. Now using shortcut method also we got the same equation. Let us come to the present slide. Right, look at this one. So the same equation we got, we can verify both equations are same. There we have done determinant, expanded the first row. Here I have used the shortcut formula, that is this lambda cube minus S1 lambda square and this one plus S2 lambda minus S3 is equal to 0. It is a easy with my experience, that is most of the students they are not doing mistake when they are using this formula, whereas expanding the determinant most of the students they are doing the mistakes, right? So it is better to follow, and the same equation as usual solving. The previous slide we have explained how to solve the equation. We can use scientific calculator, we can do the factorization, we can use the synthetic division, your wish, depends on the student skills, they can use any one of the method. But the main point to be remembered, it is a cubic equation, we have to write 3 eigenvalues, that is lambda is equal to previous one that we got same roots 1 comma 1 comma 5, because same equation solving we get the same roots are the required eigenvalues, So this is a method to find eigenvalues of a matrix 1 1 5. Okay, I hope everyone can understand easily and they can find the eigenvalues in both the methods, right. The first method, that is the expanding, and the second method, shortcut formula lambda cube minus s1 lambda square plus s2 lambda minus s3, where s1 trace of the matrix, s2 sum of cofactors of principal diagonal elements, and s3 is dept of the matrix. Solving we get the roots, right. Check also same, sum of the eigenvalues is equal to 5 plus 1 plus 1 7, and determinant trace of the matrix also 7. Your eigenvalues are correct, that it is a verification. So with this one I am closing my video lecture. So thank you